So you can also, what you can do is you can also make a note of the formula in terms of the comparison of intensities. You can write it as M2 minus M1 equals to log of I2 over I1, or in terms of the intensities, I2 over I1 equals to 10 to the power of M2 minus M1. You can remember these two relations. That is in terms of the intensities of the earthquakes.
This is the equation?
Yeah, this is the formula.
It's the same one?
It's the same thing, I'm rewriting it. So the general formula is this, right? M equals to log of I over I naught, correct? This is the general formula which you have for the earthquake. And this one, when you are comparing the two earthquakes, then you can modify it. So in terms of the intensities, I2 minus I1 will be equal to 10 times M2 minus M1.
So then this is general formula, there is the comparison?
This is the general one.
Okay.
And this one comparing the two magnitudes, and this is comparing two intensities.
The first one is comparing what? Two magnitudes.
Yeah, comparing two magnitudes. And this one is comparing two intensities. So if you know the formula, all these steps can be avoided.
That is general formula.
Are we good? All right, let's look at one more question. Okay, we'll look at the one which I was mentioning. Okay, here. This is for the brightness. It's the same formula as the magnitude of the earthquake, which is very similar to that.
You will work this question also?
You want me to? Have you all done this one, 11 and 12? Guys, here, see, I don't have much time. So you need to tell me very quickly what you need, what you don't need it. Now, question number 11 and 12. I'd given you an additional sheet where it compared the intensities of or the loudnesses of different sounds. So these are easy questions. Well, let's pick it up quickly in terms of the loudness. Yeah.
This 11 is talking too much.
What happened? I know, you tell them to be quiet. You should tell Masuma. You're. Okay. How many times as intense is the sound of a shout as the sound of a whisper? So the sheet which I given you all, so give me the loudness of each one. What is the loudness of a shout from the? So loudness is given to you as 60 decibels.
No, it's 80.
80?
60 is normal conversation.
Okay. So now the intensity of the shout to the sound of the whisper. Whisper is 30.
Whisper is 30.
Yeah. So the loudness of the whisper is 30 decibels. So take this one as the loudness of a shout as LS, and then of the whisper as the LW. So we know the general formula, right? What is the formula for this? Loudness. Loudness equals to 10 log of I over I naught, and it is measured in terms of decibels. It's 80. It should be there in the worksheet which I've given you all, the second one, the lesson one. Okay. Now if you're making a comparison, remember that if you're making a comparison, there L2 minus L1 will be equal to 10 log of I2 over I1. Or your I2 over I1. Okay? You have to, which one? This is the general formula which you have. This is the general formula when you're comparing the two loudness. Okay, remember that this is by itself, and then when you're comparing the value of I naught to I. But only thing is, you know the value of I naught here. So I naught is about 10 to the power of negative 12 watts per meter square. This is the standard intensity. So remember that value. I naught is the standard intensity, which is equal to 10 to the power of negative 12 watts per meter square. So the standard intensity of the sound is given to us, but the standard intensity of the earthquake we don't know. Okay, that's why we make a comparison. Okay, we know the loudness and the whisper. Then make a comparison. Use this formula. So you can write down the bigger minus the smaller one. That is for the shout minus the whisper, which is equal to 80 minus 30, which equals to 10 log of I2. I2 is your LS. Right, so L2 is your loud shout we have taken, and LW as your whisper. So 80 minus 30 is 50, equals to 10 log of IS over IW. Divide both the sides by 10. We get 5, which is equal to log of IS over IW. So therefore intensity of the shout divided by IW equals to 10 to the power of 5. For IS, equals to 10 to the power of 5 times Is. So the intensity of the shout is about 100,000 times more than that the intensity of a whisper. So this should be whisper, sorry. This should be whisper. So the values are pretty large. That's why it is converted into decibel. Now the same thing you can repeat for number 12. Okay? Only thing is you need to know what is the intensity, how many times as intense the sound of loud stereo to the sound of the rock concert. So you need to know the 2 decibels. So one is given to you, the second one take it from the chart. The chart which I given you, right? Yeah, the intensity chart. There are 2 charts. One is for the earthquakes, the other one is for the intensity. What? What's that, Divya? Sorry. So 12th question, we need to, from the chart, give me what is the intensity of the rock concert from the chart, the worksheet which I've given you.
This one? No, it's the formula.
Not there, my dear.
I don't have which website, Papa?
This one.
This is the chart.
This is GH1. Here. This page. Yeah, there, next page. So from that, take out the intensity of the rock concert. It's 150.
And this chart.
Okay, so here the loudness of the car stereo is given to you, which is about 110 decibels. The loudness of the rock concert equals to 150 decibels. Alright, so once you have that, use the same formula. Divya, the same formula you will be using. L2 minus L1, which is equal to 10 log of I2 minus I2 divided by I1. So this is your L2 and this is your L1. The larger minus the smaller you can take. So LR, this is the rock concert minus the car stereo, will be equal to 10 log of the intensity of your rock concert divided by the intensity of the car stereo. Okay, so substitute those values. 150 minus 1 is 10 log of IR over IC. So therefore your this value can be written as 40 divided by 10, that is equal to 4, equals to log of IR over IC, or IR over IC equals to 10 to the power of 4, or IR equals to 10 to the power of 4 times IC. Are we okay? They're not too complicated. That's what I'm saying, right? When it comes to your exponential functions, they're very easy. Only thing is you need to know those 6 formulas and you should know how to use those, apply those. We have done half-life, we have done doubling time. This is the intensity questions, the earthquake which we have done. One question, if you want, we can use the pH question and we can finish that pH value also. That's also not too complicated. Okay, this one is simple. What is the formula for pH of a solution?
Negative log of hydronium concentration.
Which is equal to, either you can write it like this or sometimes it is written as pH like that, which is equal to minus log of
H plus. Do you have to put
the
the square brackets?
concentration of ions.
Do you have to put the square brackets?
It's better because we are talking about a molecule, right?
Okay.
So better to put it in the square brackets.
But that is still multiplication.
Yeah, nothing is changing.
Just different variable.
It's just a representation, communication part of it. Okay, now what is given to us? The concentration is given to you. So here it is 0.01. So pH equals to minus log of 0.01, or this is nothing but minus log of 10 to the power of minus 2, because 0.01 is 10 to the power of negative 2. Use the power rule. Negative times negative 2 is 2. 2 log 10. So that is pH. We know that log 10 equals to 1, because the base is 10, right? So the value of log 10 to the base 10 is 1. So therefore your pH of a solution equals. Similarly, do the same thing here. So again, pH of a solution. So pH equals to minus log of 1.5 times the power of negative 10. Either use your calculator or split it. So this is multiplication, so that means you have to add, correct? So negative, open up the brackets, log of 1.5 minus log of 10 to the power of negative 10.
Is it plus?
This is plus. So that will be equal to negative. What is log of 1.5? 0.
17609. So
1.17609. Okay, 1761. This is plus times negative, that will be minus 10. So what is 1761 minus 10 times, so this will give you positive. So it is
9.8239.
9.8239. Okay. So that is your pH of a solution. So you can approximate it to 9.8. So the pH of the solution is 9.8. Now reverse that in question number 10. Here the concentration of the hydronium ions are given. So that is H plus equals to, oh, the pH is given, sorry. So pH equals to 8.5. So use the same formula. pH of a solution equals to minus log of Okay, all right. So next step, substitute that value 8.5 equals to minus log of concentration of the hydronium ions. Now get rid of that negative sign. This becomes minus 8.5 log of the concentration of the hydronium ions. Now use the conversion, that is log to exponents. So therefore, the concentration of the hydronium ions equal to 10 to the power of minus 8.5. All right. So this equals to what? What is 10 to the power of negative 8.5 equals to?
Sir, it's 0.000.
So you don't have any conversions?
3 times 10 to the power of negative 9.
Yes.
3 times 10 to the power of negative 9. Okay.
You have a punch there? Punch yourself?
Hole punch is there at the back. Okay, the concentration of the hydronium ions is 3 into 10 to the power of negative 9. Now, one other question I'm going to ask you is, what is the unit which is used? What is the unit for the concentration of hydronium ions? It is moles per liter. Make sure that you express it in terms of its proper units. Okay? Because the same thing you can repeat for B also. Is exactly the same process. Are we good? Right. So we did pH of a solution, half-life, doubling time. We have done the questions relating to the financial math. Okay. And we have done questions relating to your loudness. We've done the questions relating to your earthquake. Most of these questions are similar to each other. Okay. They're much more easier compared to any other chapter. So in most of these questions, there is only annual calculations. So that makes it easier. So make sure to remember these equations. So do you all know how to solve these? Yes, no? Solving the exponential equations. This is page 485. Okay, let's do two questions. Question number 5, page 485. So what you need to do is you have to start looking for some patterns here. So let's look at C here. Okay, C is 1 over 4 to the power of x plus 4, which equals to root of 8. So if you see this, there is not much of a comparison which you can make, but there is a pattern. So this is a multiple of 2, this is also a multiple of 2. So let's try to express it in terms of the smallest multiples. So this is a multiple of 2, this is a multiple of 2. So I can write this as 1 over 2 square to the power of x plus 4, which is equal to square root of 2 cube. Okay, this is the first thing. This is all thinking questions. Nothing is going to be straightforward. You have to keep applying, keep applying. Now I can write this as 2 to the power of negative 2 to the power of x plus 4, which equals to 2 to the power of 3 over 2. Okay, so idea is to convert it into the same base. Now when you remove the brackets, so this is 2 to the power of minus 2x minus 8 equals to 2 to the power of 3 over 2. The exponent rules. I mentioned to you all, if you have the same base, so if b to the power of x equals to b to the power of y, then your x equals to y. If you have the same base, you should have the same exponents. Similarly, if a to the power of x equals to b to the power of x, then your a should be equal to b. So these are the two relations we should remember. So when you solve this, you have the same base, so the exponent should be same. So minus 2x minus 8 equals to 3 over 2. So solve this, simplify this. So minus 2x equals to 3 over 2 plus 8. So this will give you 19 over 2, which is minus 2x. Now cross multiply, or you just get rid of that minus 2. So therefore x will be equal to minus 19 divided by 4. 2 times 2 is 4, negative 19. So x equals to 19 over 4. So they're not complicated, just that you need to know how to simplify it, just the patterns. Okay, let's look at one more. Again, this is simple. Okay, D or F, which one you want to do? Or E, any one of those. This is easy because they're all multiples of 3. D? Yeah? Or E? Both are You know, quite simple. D? Masuma,
Anyone?
you tell me.
D.
This one, this one.
D. D.
D. Okay, D.
This is both.
D for doctor. Okay, 36 to the power of 2x plus 4 equals to, now you get an idea what you need to do. Then 1296. 1296, oh sorry, 96 square root of 1296 to the power of x. What is square root of 1296? 36?
Yeah, 36 grade.
Yep. So that is 36 2x plus 4 equals to 36 to the power of x.
No, 36 grade. Uh, 2x.
That will get cancelled out. No, 36
Oh, yeah.
square and square root gets cancelled out.
Sorry.
Okay, this is kind of like using calculator. How will we do it without using the calculator? But you need to know the pattern. This is the multiples of 6, that's also multiples of 6. Then you can go in that route. But or you can just say that, okay, square root of 1296 is 36. So we have the same base on the both the sides. Therefore your 2x plus 4 equals to x. Rearrange. 2x minus x equals to minus 4. X equals to minus 4. So this one you have to be a little bit more careful, because this one can create confusion.
Are we not supposed to do it in logarithmic?
No, this is an exponent, right? So where required, you can definitely use logarithms. Wherever you don't have to use, try not to use it.
I'll try to use it so I'll have knowledge.
Well, see that when you're solving for x, it is sometimes easier to just use the normal method.
Yeah. Just explore.
Okay, let's look at this one. They're not complicated, but let's quickly look at these questions. Maybe one or two questions. Okay, which one?
It was same page, yes?
Yeah, question number 8, same page. Pick one. E? Okay. 3x to the power of 2 plus 3 to the power of x equals to 30. Alright? So here you have to be a little bit careful. Use the exponent rules. So you have b to the power of m plus n equals to what? What is this?
Bm times bn.
Exactly. So you should remember these exponent rules. B to the power of m plus n is b to the power of m times b to the power of n. The moment you see a plus, it should click to you, plus minus. So since this is positive, you can write it as 3 to the power of x times 3 to the power of 2 plus 3 to the power of x equals to 30. Now factor out 3 to the power of x. That is 3 to the power of 2 plus 1, which equals to 30. Now 3 to the power of x equals to 30 divided by 10. Now 3 to the power of x equals to 3 to the power of 1. Therefore your x equals to 1. Okay? So you just have to set up those patterns. You have to know what to do. Easy? Same thing. All of these questions need to be solved in the same way. You should always think about how do you isolate the variable. Okay? Alright, let's look at one more. Alright, this one. So this is slightly different from what we did so far. So solve for 3 to the power of 2x minus 5 times 3 to the power of x equals to minus 6. Okay, so it's not that complicated. Only thing is you have to do a little bit of thinking. So 3 to the power of 2x minus 5 times 3 to the power of x equals to minus 6. Bring this minus 6 to the left hand side. 3 to the power of 2x minus 5 times 3 to the power of x plus 6 equals to 0. Now this looks like a quadratic equation, right? So now what you have to do is you have to rewrite this. So 3 to the power of x to the power of 2 minus 5 times 3 to the power of x plus 6 equals to 0. Yeah, sure. So now you say, okay, this is important, let 3 to the power of x be equal to some value a. This is the only place where you have to think a little bit more. So let 3 to the power of x be equal to a. So now when you substitute that, you get a square minus 5a plus 6 equals to 0. So now you can find the factors. What are the two possible factors of 6? 3 and 2. So negative 3, negative 2 makes it positive 6. So this is a minus 3 times a minus 2 equals to 0. Therefore a equals to 3 or your a equals to 2. So don't stop it here. You have to plug this back. So a equals to 3. So that means you have 3 to the power of x equals to 3. Or your 3 to the power of x equals to 2. So in this case it is easier. So that is to the power of 1. So therefore x equals to 1 in this case. What about here? You don't have the same base. So in such places you can use logs. So here log of x equals to, or x equals to, you can write it as, if you want you can take both the sides. So therefore you are applying logs.
Log 2 base 3.
Yeah. So x will be equal to log of 2 to the base 3.
0.63. 0.63.
Yeah. So therefore your x value will be equal to log 2 divided by log 3, which equals to 0.6.
309.
Okay, 631. So x equals to 1 and x equals to 0.631. Therefore your x value equals to 1, 0.631. So many places you might have to use log both the cases, but in this case it's pretty straightforward. So you got the first value and the second value, of course, because the bases are different, you have to use the logarithms to solve it. Are we good? So exactly how we have done this, you have to solve the logarithmic equations also. Which is exactly same as the exponents what you have done, but only thing is these are logarithms. Okay, there are two ways of doing it. Alright, so the first thing is either you can convert it into its exponent form. So we have log of 27 to the base x to 3 over 2. Therefore there is another way of doing it if you want to solve it. I'll show you the other way. Okay, so log of a, okay, write down this relation, log of a to the base b can be written as 1 over log of b to a. You can switch bases. The reciprocal. When you take the reciprocal, you can always flip it. So if you want, you can do that here. So this can be written as log of x to the base 27 equals to 3 over 2. We don't need to do it because we are trying to solve for the x value. So I'm saying there is an option, but we don't have to do this because what we are doing is we are bringing a larger base. So let's use the exponent rule. So x to the power of 3 over 2 equals to 27. So I need a base, I need a power of 3 over 2. So if I need a 3 over 2, what am I going to do here? If I'm going to multiply, forget an exponent of 3 over 2, I have to also multiply 2 over 3. Just to create the same exponent. Okay, this is all thinking questions. You should know that what strategies are you using to solve it. So therefore this can be written as x over 3 over 2, 3 to the power, x to the power of 3 over 2 equals to 27. This one you can bring it inside, 2 over 3 to the power of 2. Okay, now we can apply that rule. A to the power of x, which is equal to b to the power of, a to the power of y. If a to the power of x equals to a to the power of y, your x equals to y. Are we good? Yes, no?
Same base, different.
Who's not understanding? Mama. Okay, tell me. So what we are doing is, since we have a 3 over 2, I'm creating a power of 3 over 2. So if I want to create a power of 3 over 2, that means I have to do the opposite, like multiplying and dividing, adding and subtracting, right? So if I want 3 over 2, because there was only 1, right? So I want a 3 over 2 there. On 27, it is 27 to the power of 1. But I need a 3 over 2. So that means what I'm doing is I'm bringing an exponent of 3 over 2. But this is an extra thing which I brought. So if I multiply by 2 over 3, which is equal to 1, right? Now we know that x to the power of a to the power of b can be written as x to the power, x to the power of a to the power of b. That's power rules. Yeah?
But for that rule, that's the same base different exponent, right? The first rule, which is x equals to y,
Yeah.
right? But shouldn't it be different base, same exponent?
So we have the same, what we are trying to do is create the same exponent. Oh, this one is same base, right?
Yeah.
So we can do the other one. That is, instead of taking the same, this one, okay, we can use the other rule. That is, when you have uh,
Different base.
a to the power of x, which is equal to b to the power of x, therefore a equals to b. No, we did the other one, right?
Yeah.
We want different bases but the same exponent.
Yeah.
So then a will be equal to b. So what we are doing is creating the same exponent so that we can relate it to the bases.
So x is equal to.
So what we see here is the same exponent. Okay? So we have the same exponent. If you have the same exponent, the bases should be same. So therefore your x equals to 27 to the power of 2 over 3. What is 27 equals to?
3 to the power of 3.
Exactly, because you need to get it in terms of the index. So 3 to the power of 3. So this can be written as 3 to the power of 3 to the power of 2 over 3, which is equal to 3 to the power of 6, which is equal to 3 to the power of 2. Therefore x equals to, okay?
I use logarithms.
6 over.
That's what I'm telling. Don't use logarithms. We are working with exponents.
No, I get this, but I tried a different way.
Yeah, you can do it anyway. But what I'm saying is, you can use even this method too.
Yeah.
Okay?
When
So you can
wrote that,
flip it.
I tried to continue.
Yeah, you can use this method too. You can just flip it and then bring it in the same form.
Logically great.
Big difference. Jeez. It was 127 divided by 3. No, 3 divided 3 over 2. So log x is equal
Because
to,
log, you can do log is
so
easier.
it's going to be
This
10 to the power of log 27
Okay?
divided
Now,
by
guys, this you can use the same thing. You can use this method which I've shown you all. That what I was saying is, if you don't remember the rule, you don't have to do it. But if you don't remember the rule, you can use this method. If you remember the rules, then it's perfect. So how do we do it the other way? It's the same question. So we have log of x, doing the other way. Log of x to the base 27. No, log of 27 to the base x, right?
Yeah.
Okay. Log of 27 to the base x equals to,
2.
what is that value? Equals to 3 over 2. So if you use this rule, the flipping of it. So this can be written as, therefore, log of x to the base 27 equals to 2 over 3. Okay? So what we are doing is, we're taking log of a to the base b equals to 1 over log of b to the base a. Applying this formula. So if you want, I can write that extra step. Alright? If you all need, I can write this one extra step. So this can be written as 1 over log of 20, this one log of x to the base 27 equals to 3 over 2. Now if I flipping it, right? So therefore your log of 27 to the base x equals to, no, this one, right? Log of x, sorry. So log of x to the base 27 equals to 2 over 3. If you flip this, you have to flip this also, right? So I'm flipping it. So one comes down, this goes up. Just one step. So therefore, your x equals to 27 to the power of 2 over 3, or which is equal to 3 to the power of 3 to the power of 2 over 3, which is equal to 3 to the power of 6 over 3, which is 3 to the power of 2, which equals to 9. Equals to 9. Are we good? All right, I want to look at one more question.
So you want to drive all the way home and then bus all the way back down? Yes. If you really want to, if you really want to,
All right. So in this case, what we are doing is you're checking for the inadmissible roots. What does inadmissible roots means? What are inadmissible roots?
Negative?
So any roots which will make the function undefined. That doesn't work, ma. Here, take this. I should throw this away. It doesn't work. So went into the garbage, that's okay. So inadmissible roots are those roots which do not work. Like if you substitute back, then the logarithm doesn't work, doesn't exist. That are inadmissible. Inadmissible roots. When you solve it, you will get the roots, but you take that roots and plug it back into that equation. That logarithm doesn't exist for that. Let's do one so that you'll get an idea. So we'll do the sixth one, number 6 first, then we'll come back to 5.
This question was in which section? 491. 491? Yep.
You don't have your textbook around you?
I'm just copying your this one.
All right, let's simplify. Apply the rules. Now log of a plus log b. What is log a plus log b? Or log of m plus log n equals to? What is log m equals log m plus log n? log of mn. Please memorize these rules. Okay, now let's apply that. You have the same base, that's 6 and 6. So you can write this as log of 6 x times minus 5 equals to 2. Now convert the log into an exponent. So x times x plus 5, oh, sorry, equals to 6 to the power of 2. So that is x square minus 5x square minus 5x minus 36 equals to 0. So what are the two possible roots? So minus 9 plus 4, right? So this can be written as x minus 9 times x plus 4. So therefore your x equals to 9 or minus 4. Now if I plug in the value of x back into this equation, so log of when x equals to 9, log of x, or that is log of 9 to the base 6, log to the base 6 times 9 minus 5, which is equal to 2, right? So here this is positive, 9 is positive, and here log of 9 minus 5 is 4. So this is also positive. So that means these exist. Now when you look at the second one, when x equals to minus 4, plug in the value of this equation. We get log to the base 6 minus 4, log of 6, log to the base 6, that is minus 4 minus 5 equals to 2. This is log 6 minus 4 plus, yeah.
I think we did mistake on 9 minus 5 is 4. No? No.
It's both positive. It's still good.
9 minus 5 is 4. It exists. That's why I said that it exists. I'm not solving it. I'm just checking for existence. Now this is minus 4 and this is log of minus 9 to the base 6 equals to 2. Now log of any negative number does not exist. So this does not exist. This does not exist. So therefore negative 4 is not admissible.
It will ever be imaginary.
Don't worry about imaginary. We are looking at the real values, right? Not admissible doesn't mean it does not exist. It means that it does not follow those rules. Sorry? Yeah. So I'm going to try this because see, I'm recording this session. I got that hint from Khwaja the other day. Khwaja came and showed me how to record it. I'm not sure how it works. This is the first time I'm doing it.
You should do that on how you derive the equations of motion all the way to momentum.
I know.
And it's a long way. You know how you derive the formula?
First time I'm doing it.
Multiply by such
We can check.
No, you can see that I'm doing it for the first time. You can see that recording part of it, right?
One day before also you were recording us.
It didn't work. I'm just hoping that it will work today. Alright, anyway, so what you have to do is you have to check for the admissible roots. So check for admissible roots means when you solve it, when you find the possible roots, you have to check, means you have to plug it back and see if that logarithm exists or not. Okay? Now these ones are very easy, but if you want I can take one. Let's look at ones which are complicated. So, as long as you'll know how to use the laws of logarithms, laws of exponents, it should be very, very straightforward. That's why practice those rules or remember those rules. Okay, let's try one. Pick one. Masuma, pick one. You are the lucky pick person. B?
D. D.
T?
Yeah, D.
You can do DB in both.
No. Tell me
D,
one.
D, D, D.
Okay, D. So log of 2x plus 1, this is because it's to the base 10, plus log of x minus 1 equals log 9. Okay. And again, this is not that complicated. Okay, this is something again, you use this rule, right? Log of a to the base b equals to, log of x to the base b equals to log of y to the base b. If you have the same base, both sides, x equals to y. Okay, very straightforward. It's like the exponent rules. Alright, now let's simplify this. This is addition, so you multiply. So log of 2x plus times x minus 1 equals to log a. So you have both the sides log to the same base. So your log gets cancelled. We should not say that.
Is it acer or 9? Log 9.
Is it 9?
9 or 8?
Oh,
9 or 8?
then it's easier. Okay, 9. 9.
Log 9?
Alright, so that is 2x plus 1. Therefore, 2x plus 1 times x minus 1 equals to 9. Now expand this. 2x times 2x is 2x to the power of 2 minus 2x plus x minus 1 equals to 9. So that can be written as 2x square minus x minus 1 minus 9 equals to 0. 2x square minus x 10 equals to 0. So 2 minus 10, 2 times minus 10 equals to minus 20. So we need negative 1. So negative 5 and positive 4. So this we can write it as 2x square minus or plus 5x minus 10 equals to 0. So rewriting these, you have to be careful. Just group them in such a way where you can simplify it easier. So that is 2x times x plus 2, 5 times x plus 2, so 2x minus 5 times x plus 2, which equals to 0. So therefore your x value equals to 5 over 2 or x equals to 2. If you have any inadmissible roots here. If you take x equals to negative 2, definitely this does not exist, right? Because it becomes negative. Because this one is not admissible, you can't use any of them.
Can you use chart for that, sir? To find negatives or no?
Which one?
The chart in the table.
Yeah, you don't need that. You just have to check whether it is admissible or not. When I plug in the value of x equals to 5 over 2, yes, this is positive, of course this is 9, so it is admissible. Minus 2 is not.
You have to put restriction that log x cannot be 1.
Equal to minus 2.
No, go up, sir.
Where?
Yeah. Can you put a restriction on that x cannot be negative half and x cannot be...
No, because why? This is not a reciprocal function. Okay? If you have reciprocal only, then the asymptotes are there.
If x is equals to negative half, then it's going to be log 0.
Where is half?
Half. Log.
You cannot, because there is log 9 on the other side. That's not a complete solution. If this was 0, then you can think about a lot of things. Right? This is not 0, this is 9. There is a value here. Then you can't put a restrictions when you have something on the right hand side.
Because if x is equals to...
Okay, if x equals to negative half, you're saying.
Yeah.
But that's not a part of the solution also.
We just have to solve for x.
Yes. What we are doing is we have to solve for x, and then after solving for x, you have to decide whether it is admissible or not admissible. Okay? You can't randomly take values there. So anyway, so when x equals to minus 2, the function of the does not exist. Okay, you can substitute and show that it does not exist. Therefore, x equals to minus. But one thing, remember that just because it is negative, it doesn't mean that it does not exist in all the cases. There might be cases where it might exist. Alright? So you have to be careful. Unless until you don't plug it in, you will not know. So in this case, if I take negative 2 and plug it into this equation, negative 2, negative 1 is negative 3. So it's not admissible. If this is not admissible here, it's not admissible anywhere.
So the only value for x is 5 over 2?
The only solution here is, only admissible root is x equals to 5. Therefore, x equals to 5 over
The only one that has positive.
Yeah, this is the only one which is admissible. Alright?
It took 15 minutes to do that. He just wasted 15 minutes of his life. It's almost done. That took 15 minutes.
I don't know how to put a phone. Normally when I play that, it just...
He was on flex mode.
I'm sorry. I know.
29 seconds left.
I've never asked this like...
Okay, question number 9 is very similar to what we have done. That is, it's nothing but a loudness equation. Okay, I would definitely encourage you all to do these questions, especially question number 10 and question number 11. They're good questions, 9, 10 and 11. So now you all have an idea how to do it. It's a good idea to solve some of those questions. This is page 492. So we have done some questions based on pH solutions, right?
How do you sign these? Okay, let's do it. This one
Okay, almost all these questions are very doable. They're very simple, straightforward questions. I don't see anything complicated here. Definitely, I'll encourage you all to work on those. And rates of change, see, just because I'm asking you all to do this, I'm not saying that, oh, this will be on the test. Okay? So the rate of change, I want you all to do it just to get an idea. 1 or 2 questions only want you all to do. Because the rate of change, you have done it in the polynomial functions. Do 1 or 2 questions here. Try working on those rates of change in 8.8 and see what the answers look like. Okay, just to understand the rates of change. And if you have questions, definitely we'll clarify that. But I need you all to try 1 or 2 and say, okay, I do it, I understand it. The second thing is, I tried these 2, I didn't understand it. Then we can take it up. Okay? But I want you all to try. Because the concept is the same. Okay, for your test on Tuesday. What? Tuesday. Okay. So make sure that you all work on this practice questions. That is on page 510, 511. Page 510, 511. Page 510 and 511. Chapter 8. So this is pretty straightforward. 8.1 we have done. 8.2 are pretty straightforward. Then 8.3 is just about transformations. So don't worry about transformations. I'm not going to give you all any questions on transformations. Okay. So 8.2, even if you don't want to do it, it's fine, but try working on those questions just to understand. 8.3, they're pretty straightforward. 8.4, we have done questions on that. 8.5, we have used now exponential functions. Then there is this 8.6, the solving the logarithmic questions. And these word problems, they're pretty straightforward. This is on loudness. There is the magnitude, the pH of a solution. Okay. Then there is this exponents, that is half-life, mean life. So 8.8 you don't have to do it.
8.8?
Don't do 8.8, but I want you to do it for the sake of understanding it, okay? 8.7, we have done most of these questions. That is pH of a solution, intensity. 8.6 is, yeah, that is 8.6, you have that intensity question, loudness, right? Then 8.5 is half-life and mean life questions. Half-life, mean life, or the doubling time. Then loudness of sound. Then earthquake, that is magnitude of the earthquakes. So these are 4-5 the ones which I given you, the worksheet, right? Just do that, those kind of questions. You have the formula sheet, you have those questions, you should be good. And for grade 11s, I'm going to post the review sheets on the Brightspace. So keep an eye on it, all right? For the test review sheet. You people also have on exponents. The test is on exponents. Okay? So it will not be that hard, be easier. That's on Tuesday. Okay?
Teacher.